Problem number 773, sliding puzzle. On an 2 multiplied by 3 board, there are 5 tiles labeled from 1 to 5, and an empty square represented by 0. A move consists of choosing 0 and a 4 directionally adjacent number and swapping it. The state of the board is solved if and only if the board is 1, 2, 3, 4, 5, 0. Given the puzzle board, return the list number of moves required so that the state of the board is solved. If it is impossible for the state of the board to be solved, return -1. Okay, so the game is like so you can only swap with 0 and the adjacent number. Okay, so 1, 2, 3, 4, 0, 5. You can then become, there will be so 1, 2, 3, 4, 4x5. It can then be 1, 2, 3, x4, 5, or it can be 1, 2, 3, 4, 5x, or it can be 1x3, 4, 2, 5. So there are 3 possible. Okay, so this will be we can see this problem as a BFS problem, so that one move, when this state can be swapped into another state, then these two states are connected. So since I think so we need to make this into a graph, and since the board is always 2 multiplied by 3, we can use it as tuple, like 1, 2, 3 x 4 0, 4, 5, like or string. We can use string like 1, 2, 3 0, 0, 4, 5. Like in the beginning the board will be 4, 0, 5, like this. And the starting and then the ending board will be 1, 2, 3, 4, 4, 5, 0. Okay, it will build the graph and try to transform. I think we'll not build the graph first because we can do the BFS at the same time while finding the possible moves. So okay, we will just change. We will have the function encode and decode to encode the board into the string and decode the string into the board. So df encode, we will have board, list of this int and into string, and we will have decode, and that will be string into board. So for encode, we will return board 0 with join plus board 1 join. We'll separate the lines with hash, and then we will have decode the string, so return split string. Oh, sorry. String has to split. And then I think it will be like rows equals string split and we will have we'll have 2 rows and then return rows 0 split and with rows 1 split. Okay, and then we will have our ending word. Ending string will be ending word is this, and then ending string will be encode ending word. And then we can start our BFS. So for the BFS, we'll our starting string. We'll encode the starting word. Then we'll have our BFS queue, which is Q, the Q starting string. And we'll have a visitor sub that we will not visit the same string again. So while Q is not empty, we will run. And while in range of Q, we'll only pop with the size of Q. So this will be the word string. And we should we should look at the connected state of this word string, which means the possible swapping that we can make from the word string. And we should look at every possibilities to check if there is an ending word. If there is, then we can return the number. We can return the moves. So we'll have a move count equals 0 first. And if starting string equals ending string, then we don't have to run the BFS. We can return 0. That means we need 0 moves. And then if we need to run BFS, then that means the starting string is not equal to ending string. Then we will add move by 1 when we start. Okay. So now we need to swap to return the possibilities of the swapping results. So the first thing that we have to find the 0 at the location of the 0, and then we swap. So we will have a function called swap string. Let's swap the string of the board. And string will give a string, and we will return a list of string that is the swap that is the possible swapping results. Like if this, then we will return three strings, like 1 2 3 hash 0 4 5 1 2 3 4 5 0 and 1 0 3 4 2 5. These 3 strings will return, and then we will check. So we would write like for swap string and for possible swap string and swap string board string. Then if possible swap string equals to ending string, then we can just return the move and we finish the game. But if it is not the ending string, then we have to check if it is in the visited set or not. If it is already visited, then we don't have to check the possibles of this string because we have already checked it before. But if it's not in the visited set, then we will have to append it after into the queue and check it later. So check its possible swapping as well. So if it is not in a visited set, we should add it right away. And then we will append in the queue. Okay, and if we after running, if the queue is already empty, so that means we traverse all the possibilities, then we do not find the answer, then we will return -1. Okay, then we will now write the we have to find this possible swap string. And that will be we should find the 0 location first, so we will have to decode to the board. So decode the string and for row and board, for I in range, two, for J in range, 3. If board I J equals 0. Decode. We should put we have made all these to be string, so this is string. Like it does not matter because then ending board encode we can like change these strings to integers as well. but I'm not going to do this right now since we are in the urgent. So if board ij equals 0, then we will return, not return, like 0 location will be like 0 location will be ij. Then we will start swapping. So if I plus, this will be up. If I minus 1 is smaller than 2 and it's larger or equal to 0, that means we can swap with the upper so and have to swap these two. That's swap ij with I minus 1j. Then that means board ij ij and board I minus 1j will swap. Like this, and we have to init board every time since it's gonna be changed. So append encode board. this is up, then we will have down. So down will be I plus 1, so we will change this to plus. Yeah, we can write for loop to check every direction, to check the 4 direction. But I will first write this tedious code so that it's more easier to read. J minus 1, so it's left, and this is 3. And we will have J minus 1. And we will have the last direction, which is right. And this will be J plus 1. And we will change minus to plus. Okay, and then return result. Okay, so then, yeah, for example, the encoding, we will try run and see, like example 1 will have board 1, 2, 3, 4, 0, and 4, 0, 5. So we will encode board 0, so this row, join. Okay, I'm not sure if Python has this join method, but yeah, it will join the list into a string 1, 2, 3 plus hash, and we'll join the second row, so it will return. Okay, start string will be like 1, 2, 3, 4, 0, 5, and end string will be 1, 2, 3, 4, 5, 0. Okay, and these two string are not the same, so we will not run into this condition, but we will move on to the BFS part. So we will have a queue which has the starting string inside first. The visited set will have the starting string as well. The move is default to 0. Then we'll start the BFS. So we will first run, since the queue has only one element, we will only run this for loop once. So word string is now the starting. We'll have here, and swap the string. So we will have this as the parameter and swap. So for I in range 2, yeah, we'll have to first decode so we'll have to first decode the string and find the 0 location. So the 0 location is ij, then think it will be better yeah, we'll have I we'll have break, and then ij will be stopped at the location of 0. So yeah, so for okay, so for I, so this will be I will equal to 1 and j will be equal to 1. So can it swap with the upper square? 1 minus 1 is 0. Okay, so we can do. So we have a new board now, and then board 1 1 will be swapped with 0 1. Okay, and after swapping, we encode new string, so it will have 1 0 3 with 4 2 5. And can it swap with with the lower square? I is 1 1 plus 1. Okay, it's larger than it's 2, so it is not going to run into this condition. And 1 minus 1 is 0, so yes, we can swap with the left square. So we will have 1 2 3 hash 0 4 5. And can we swap with the right square? 1 plus 1 is 2, so yes. So we'll have 1 2 3 hash 4 5 0. Okay, so we have the 3 in the result, and we will check the first one, 103. It's not ending string, so we will not run into the first condition, but we will add it. It is not in a visitor set, right? Our visitor set will have the starting already, and then we will add the second, this. Okay, and then for another possible swap string, it's 1 2 3 0 4 5. It's not equal to it's not equal to the ending string, so we will add it. This one. And then append to the queue. Okay, so this already queue, right? Sorry, we'll have queue like first of all this, and then we popped, so we will have this 2 added, and then turn to the last possible string, 1 2 3 4 5 0. Is it equal to the ending string? Yes, so it will return 1. Okay, let's run. Oh, I think I'll have Python join this. Oh, you have to write it. So you have to write it like then we have to change it to string. Yeah, it's not or maybe we use tuple, like tuple. Not sure if it's if we use tuple, maybe like board 0, board 1, and then the code will be tuple int. So we will have this 2, 0, and this 2, 1. This of tuple, then we will have swap tuple. We just I think we will maintain the string first, but yeah, we will we will have result equals string and then for loop I in range range 2, and then I think I'll have like a map or 0, or reduce, or 0 with lambda. You can like resolve for loop I in range 2, for loop j in range 3, and then result append result O plus word ij. You will add a hash, and then we will we should remove the last hash. So result okay, if I equals 0, then plus. Okay, return result. We will change this to string, and then when we decode, split we'll have to make it to int. So this will be 0. And split the hash, and we will have to make it to int. For row 0, yeah, like for now we have 1, 2, 3, 4, 5, 6, 4, 5, 0, and we need to change it to 2 arrays. Can we just make it like yeah, but we also need to change it to integers, so we have to okay, for value in rows, no, for r in rows, and for value in r. this is we have to we create an array and append the integer value into the array and then append for the rest result, like array and then array append integer value, and then after that we will append array and then return result. Maybe something like a typo or so, and make this mistake. Okay, basically it's this break here. It only breaks the first for loop. So okay, I'll have like found equals false. Break. I'll have found true. If found break. Okay. Yeah, I think the bottleneck is like keep encoding and decoding and here in the swapping string. So maybe I can optimize this part.